Okay, welcome back. This video is going to focus on this parts washing cabinet that I picked up on Craigslist last weekend. Now, I've been looking for a parts washer for quite some time now, and mostly in the used market. Couldn't really find anything that suited me, and this thing popped up. It's $50 is the asking price, and went and took a look at it. Needs a little bit of work. It was advertised as non-functioning, so we're going to take a look at it today and figure out what it's going to take to bring this thing back up to usable condition. As a lot of people know, I'm working on the Big Cat generator. That's a pretty dirty machine, so I'm going to have a lot of little parts to degrease and clean, and this will come in handy for countless things. So let's get into it. Alright, let's take a close-up look at this unit real quick. Kind of has a vintage look to it. Almost looks like a big chest freezer. But it's made by a company called Kleer Flo, which they're in business in one form or another still. And this was a pretty common model of theirs. I think this is from the mid-1970s through to the mid-80s. But I can't be quite sure. But it's pretty basic on the inside. Solvent brush, there's a tank here. This removable kind of basin here, and it's got a pipe with some holes drilled in it here. And that runs all the way along and along the bottom here. And I imagine the pump's discharge must split, and you get kind of a stream out of this pipe here, and then you can kind of work at it with the brush as well. So the pump assembly, this big cast aluminum box here, and I'm assuming that's some kind of filter screen. Now this whole tray lifts out of here. This kind of thin wall tube is a slip fit in this fitting down here. And that allows you to lift the whole tray out as a unit. So again, like I mentioned earlier, it was sold as non-functioning. The pump does not work. So we're going to investigate that today and figure out what it's going to take to make it work. Here's a shot of the data plate. There's not much to see. I had tried to remove this paint. Somebody painted over it. And as I was removing the paint, the silk screen kind of was coming off with it, so I stopped. But you can see it says Kleer Flo Company. That might be a model 282 there. I don't know. But looking over in the front here, we got a toggle switch, which isn't really being held in. Odd thing is, it's a single pole double throw switch, so it's got a center position, and then it's got a position down and then a position up. So we're going to investigate that. That's a bit strange, but again, that's not really held in. The power cord also is pretty rough. I already took the plug end off of it because it was more or less falling off. So we've got a grounded cord here. Strain relief. Of course, the sheathing is broken away. So I already picked up a new cord for it. But let's dig into this. I think the first thing I'm going to do is pull this cover plate off, and we'll see what's under there. Alright, I got you guys down here with me. Let's investigate this switch operation here. Just looks like 2 screws here. Let me grab myself a light. That too bright for you guys? You should be able to see. So, big motor in there. Wow. That's got to be a 1/4 horsepower motor. Let's see. Again, the switch is not held in by any means. Huh, okay. Well, I'm not gonna just put a cord end on it and plug it in and see if it works. I believe the guy that sold it to me when he said it didn't work. So, in order to avoid doing any more damage, we're gonna do some testing here. I got the trusty fluke here, and what we're gonna do is set it on continuity or resistance. Take the hot and the neutral wires, black and the white. First, let's make sure the meter. Okay. So, we'll just wrap the hot and the neutral around the meter probes here. And see if we get any continuity through the circuit when the switch is flipped. Right now, the meter shows completely open circuit here. Completely open. Okay. Nothing. No continuity at all through the circuit, whatever position the switch is in. Okay, I wonder if we've got any continuity to ground. So first we'll just start off, we'll leave one meter probe connected to the line, the hot wire. Take the other one, we'll touch the ground wire here. Nothing, still no continuity. That's good. Anything to the chassis here? Nope, open circuit. Let's try the neutral wire to ground. Got continuity there, yep. So, to the chassis. Nothing. To the ground wire. Nothing. Now, just for the heck of it, let's try the ground wire to the chassis. We should have continuity there. Yep. Zero resistance. That's good. Let's check that switch now. Maybe the switch is just bad. Not the greatest condition. I'm gonna flip this to continuity so you can hear the beeper. Obviously, it's only going to have continuity in one direction. Double throw switches usually work something like this. So you've got the center, which is common, and then when you flip the switch in this direction, these two terminals are shorted or closed. So the common closes to this line, this leg, when the toggle is in the opposite direction, pointing away from it. And then the same goes for this direction. Not all switches are like that, but many of these double throw switches are. So, got continuity there, so it's not a bad switch. So, more investigation required, it seems. Now I have the meter probe across the other terminal here, so I should have it in this direction as well. Let me get this. Actually, yep. So, not a bad switch. I'm just gonna have to press on here. Let's see. So we've got a white wire here, black, red, a green. It's peculiar. I wonder if this. Huh. That's interesting. You see that? Did I just do that now? Let me zoom in here. See that? No connection there. When I ripped that wire nut off, they were not touching. That's peculiar. Boy, that's I got. let's reconnect those real quick and see if, where are you? Right there. Let's reconnect those two wires and see if we get continuity through the circuit now. Couldn't be that simple, could it? Let me get a pair of wire strippers real quick. I wasn't prepared. Didn't bring the wire strippers. Well, wouldn't that be funny if it was just a bad connection? I'm still going to replace that power cord even if it was just a bad connection. But it'd be nice to not have to pull the motor out. So let's twist them together real nice. Take a look in here while we're at it. That appears to be a decent connection, although greasy. And that one as well. So let's see, let's close the switch. Go back to the cord here and see if we've got any continuity between line and neutral, hot and neutral there. Oop. Should get my alligator clips. Nope. Nope, still open circuit. Yep. Not gonna get lucky there. Okay. Well, what I originally wanted to pop that wire nut off to see was if this white wire here is the same white wire in this cord. Yep, that's closed. So they're switching the neutral. Well, that's not the best thing to do. Oh, man, all this rough wiring. What about this black wire here? I wonder if this black wire is the black on the cord. Let's see. Appears to be going in a different direction than the white wire. Can't really tell. Can't see much through there. And I think I'm going to have to drain, if I want to pull that motor assembly out, I'm going to have to drain some of the liquid, some of the solvent. This wrapped around here. Nope. Alright. Let's see if we can take a closer look in there. And that white wire just kind of goes around the back of the motor there. Then we got a black, a red, and a green. Looks like they go right up into the motor. Well, I think we're going to have to go for it and remove the motor assembly. Kind of an interesting wiring scheme they have here. Line cord comes in through that strain relief, and they have it running through a piece of plastic tubing using compression connector fittings, I guess, for a seal. It's still fairly flexible. It's peculiar. Alright, let me get this tub out of the way. Get probably maybe 5 or 10 gallons worth of this solvent out of here, and we'll pull this motor. Looks like in order to do that, we're going to have to take all these little screws off. And I'm guessing that big cast aluminum assembly inside will come off and we can pull it right out. Stand by. Alright, well, I've drained about 10 gallons of liquid out of it. That got the level down to where it's below the or significantly below this cutoff point, so I don't have to worry about it leaking out. Pull the little nozzle off, so that's a pretty good length there, flex, but I think it's broken down at the bottom. Also snipped off the power cord and took this little flange off, sorry about that, and found more pretty poor connections there. I mean, that one again just broke. This one's about to break. The wire nuts were on them, but just barely. And then that's your ground point, just grounds through one of the mounting screws there. So got a 5/8 wrench here. Let's see if we can take that compression fitting off. Pull those two wires through. Just the hot and the neutral. There we go. So I think we can take the rest of these screws out and bring this whole pump motor out. Alright, let's see how this is going to work. Just go ahead and pull the rest of these screws out. You know what? Maybe you guys don't have to watch this whole thing. There's quite a few of them. Alright, pretty much one screw holding it in now. It's loose in there. And it's probably going to want to drop like a stone once I take it out. Let's see. Although there was a lot of silicone holding that thing in there, so maybe it won't drop. Actually, no, it doesn't want to drop. Sitting on its pickup. Okay, that's handy. Yeah, see how that silicone? Lots of silicone. That's a hell of a pump there for a parts washer. Wow. Yeah, it's got to be at least a 1/4 horsepower motor in there. Well, let me let it drip dry and we'll put it out on the bench. Alright, we're over at the bench. I've kind of cheated on you guys already. I started disassembling it, giving it a little wipe down, get some of the heavy gunk off. So I took this filter assembly off, get the can, the cap, and the filter, which unfortunately I don't see any numbers on it for as far as what to reorder. I'm thinking this thing might be older than I think, because this is the media, the filter media appears to be like either like a cloth, like a woven, almost like a rope that's wound up inside here, almost like an old fuel oil filter for a furnace. Kind of see it in there, but I'm not sure what I'm going to do about that. I don't want to reuse this, so hopefully I can find a modern equivalent that'll fit in that in the housing. I've also pulled off the tube for the AC wiring and yanked out the old black and white wires here. See, they're thin little things, probably only 18 gauge or so. Wiped it down a little bit. Here's the pipe where that trough, the bucket pipe slides into, and there's actually an O-ring in there. So they took a pipe nipple, cut it, then machined it and put a little O-ring groove in there. So that's nice. I have to replace that O-ring. And there also appears there's a lever here, and almost like a drum valve or a spool valve here. You can see the orifice there. So that looks like a way to adjust where the flow gets diverted, how much of it gets diverted through the filter and sent out to the brush, and then versus how much unfiltered liquid comes out straight through the pump and then into the basin. So that's stuck. I'll have to free that up. The business end of the pump looks okay, other than there's a bit of well, more than a bit, there's some pretty significant pitting on the bottom of this housing. This is cast aluminum, and I don't know if that's some kind of corrosive action there, but it's pretty deep in places. It doesn't appear to be through, but it's pretty deep. It's hard to say what that could be caused from. That's pretty much the lowest point. There's a little bit of something here as well, but nowhere near as bad as this. It's a little bit peculiar. So I did put a wrench on the bottom of the pump here, and it does spin pretty freely, so the pump's not stuck. That's a plus. The motor's not stuck. Speaking of the motor, with all the rest of the wiring out of the way, I can clearly see, and with this better angle, better lighting, I can clearly see that those red and green wires go right into the motor itself, so that's it. And I put my meter across those two, and sure enough, there's my continuity, about 1.8 ohms. So I think before I go any further, I'm going to hook up a test cord here and give the motor a little bit of power and see what it does. So stand by. Alright, have you set up here, looking at the back of the pump, or the business end. Maybe you can see the shaft there. We're going to plug it in and see what it does. See the head of that nut there, head of that bolt? Let's see what happens. Well, that doesn't sound very happy, does it? Nope, doesn't sound very happy at all. It kind of moved, which is interesting because, sure enough, the shaft does spin freely. But, wow, you know what? I didn't even notice until just now all the end play in that shaft. You still looking at it? Yeah. Wow. That's pretty significant. You know what? I wonder if that's the rotor inside the motor has that same end play, or if that's in the coupling between the two. Let's see. Let's see if there's any way we can take a look in there. I'm guessing this motor's got a centrifugal switch in it, and that noise sounds like that the start winding's not engaged. I wonder if the rotor has so much slop that the switch isn't engaging correctly. Let's try to, I'm going to push the shaft in. Let's try it again. Let's see if it spins up now. It might not. Sometimes if you take the end play out of the rotor shaft in the opposite direction, you'll get the centrifugal switch to close and it'll start. Yeah, you see it jumped out there? Let's see if it'll go. Nope. It's trying to go, but we're gonna have to dig farther into it. Let's see what we have to do to get that motor out, or get better access to it. Alright, so this looks like soldered pipe. We don't want to mess with any of that. So it looks like I can either pop these bolts out and pop the bottom half of the pump off with the pipe and take this filter housing off, or got a set screw here. Depending on what kind of coupling is in here for the pump to the motor shaft, I might be able to slide the whole motor out if I loosen, or the whole pump rather, if I loosen that coupling. And then again, take these 4 screws out here and pull this whole bottom half off as an assembly. Then it looks like I got to pull these bolts, pull this flange, and the motor is probably affixed to this flange. Actually, 1, 2, 3, 4. Yep, those are probably the little bolts that run the whole length of the motor, kind of clamp it together. Alright, let's keep tearing this. Alright, let's keep tearing this thing down. I already removed that valve body, kind of that diverter valve. That was pretty well stuck in there. A couple of O-rings that are pretty crusty. They'll be replaced. Have the filter housing loosened, as well as the set screw for the pump coupling. You still in the shot there? Yeah. So that actually is loose. I'm thinking that's going to work, just sliding that off of there, but I could be wrong. Looks like I am wrong. Something's keeping that on there. I was hoping there'd be like a Lovejoy coupling in there that I could slide apart, but I don't think that's going to be the case. It seems like it's hitting something, hitting a good stop. Let me take that set screw all the way out. Oh. Might have to take the impeller off the pump. I'm just going to leave the camera rolling here. You guys can fast forward through this if you like. Take the lower half of the pump off. See what that looks like. Maybe pull that impeller off. These little bolts here are pretty tight. I prefer not to snap one of those off. Of course, now everything wants to flop all around. Yeah, you can tell they went right to that aluminum body of that pump. They got kind of that white aluminum rusty powder on them. Which I'm surprised. I'm surprised that there's corrosion on here being in that solvent, but that's not to say that there isn't some water in the bottom of that tank. As part of this cleanup project, I'm going to drain that tank entirely and clean the gunk out of the bottom of it. That one might be worth hitting with a little bit of penetrating oil. Grab something. Ooh, something's leaking out the bottom there. The old back and forth technique seems to work with these pretty well. Okay. Filter housing in the bottom of the pump. Nice and sludged up in there. Definitely, I would say that the impeller of that pump was contacting the outer housing. Wow, look at all that backlash. That's crazy. Yeah, I wonder what kind of coupling that is. Or I wonder if that's the motor shaft itself. It's just a special built motor with a long output shaft. I wonder if it comes all the way down to here. Don't know. I'm gonna find out. I wonder if I can grip that impeller with my bare hand enough to get that off. Probably not. Nope. What I need is a big pair of channel locks. One sec. Alright, let's see here. You know what? It's a double-sided impeller. That's interesting. Huh. It's got vanes on both sides of it. And wonder how we're gonna get that off of there. What if we just lightly pry on it? Couple of screwdrivers. Doesn't want to seem to budge. Don't want to do too much prying. I got a cast aluminum impeller, a cast aluminum housing, so don't want to do much prying on that. I wonder if a little bit of heat on that would help. Being aluminum on a steel shaft, assuming it's a steel shaft, I would think. That might help it come off. Wipe this puddle. Let's see. Yeah. I think I'm going to apply a little bit of heat to that real quick. A little bit of heat from the propane torch. Let's see if we can't convince that to come off. Let's try putting a little bit of tension on it. Nope. Definitely does not seem inclined to come off right now. I'm a little hesitant to put a puller on it. You kind of lose feel for how much force you're applying when you use a puller. I would like to get that off of there though. Maybe we'll just be patient with it. Come back to that. Put a little bit of Croyle on that point there. Well, let's take the rest of these 6/4 20s out. And I think we can still slide the motor out of the body. At least that's what it looks like. Some pretty good gasket sealer there. Somebody really sealed that up. Looks like a piece of cork. Let's see if we can get in there with a little screwdriver. Scrape some of that away. See if it'll be inclined to pop off with a chisel. Yeah. See, it's starting to move. Again, all cast aluminum, so don't want to go too crazy with forcing anything. Almost there. I think we got it. Here's our housing. Nice casting. Okay. And the motor. Oh, look. It's the unknown motor. They went and they took the data plate off of it. Whoever made that motor. Somebody might recognize that. There's a little oil cup there. Brand new, never been oiled. I wonder if that's why the bearings are shot. Oh, there we go. There's some lubrication information. Interesting. No manufacturer information though. Oh, look at that. There it is. It's a General Electric. Okay. So Kleer Flo probably took the GE tag off of that when they bought the motor. Alright. Let's see if now that the motor's out, I can explain what I think is going on here. I might not be able to, but let's see if I can. This is what I think is going on here. Let's see if I can zoom you way down in here. Grab a light. Ooh, that's no good. Strobing like crazy. So I'm looking through the viewfinder with you here. Alright, so you see that spring right there? Where am I pointing? Right down there. A spring, and there's a disc. See that disc right there? That's part of the centrifugal switch. So I'm going to rotate the shaft here, and you can see the disc and those springs. There's a spring back there. There's a weight. Another spring and a weight. So you see all this backlash in the motor shaft. Jeez, that's crazy. That's easily an eighth or more end play. Let's see if I can move you over here. Alright, so can you see the disc? And then you see what's riding on the disc right there? So what happens is, if I'm not mistaken, when the motor is accelerating, once it gets to a certain speed, the weights on the centrifugal switch fly out, and that pushes that disc in this direction here, and that opens the start winding. But for whatever reason, because the whole thing is out of spec, the rotor's not in the position it needs to be in, I don't think the start winding is actually closing. So that angry kind of buzz we heard a little bit ago was just the run winding being powered and the rotor not moving. Sorry about that. Let me zoom out here before I forget. So that angry noise we were hearing, that buzz, was just the main winding, the run winding being energized, but the motor not spinning, the rotor. So the rotor didn't spin. So I imagine we were drawing quite a bit of current there because we had no back EMF. So let's see, maybe we don't even have to take that impeller off. I imagine we're going to have to at some point, but not immediately. Let me put this whole thing in the vise. We're going to pop the back cover off that motor. Alright, let's start taking this motor apart. I would say this is probably the first time this thing's been opened up since it was built. It's not reversible. So, what's going to happen here? Since the bottom flange of the motor is held in the vise, and we're taking these 4 screws out, long, well, threaded screws or bolts, whatever you want to call them, I could probably, am I going to be able to slip the whole stator housing off the rotor? Maybe. I'm not quite sure how it's going to come apart. Before I do that, take them out all the way. I'd say it'd be a good idea to disconnect The wires go into the stator coils, but I don't think I can access them without taking this back cover off first. Should be movies right here. Oh, yep, there's a slot to get a little screwdriver in. Pop that back cover off. Now we're going to take one of these motors apart. Make sure you don't lose the little spacers. There's one right there that wanted to come off. That's how you set that end play in the shaft. There's nothing left in there. Fairly clean in here. That's a plus. Now you can really see what I was referring to earlier in regards to the centrifugal switch mechanism. So here's that disc, and here's the actual switch contacts right here. So what happens when the motor gets up to speed, this disc gets forced out and it opens the contacts for the starting circuit. But actually, I was wrong. When the weights fly out, the disc gets pulled in. So as it's resting, the disc is popped out. When the motor gets up to speed, the disc gets pulled in, and these contacts here snap open and de-energize the start winding. But, so why wasn't that working at all? Probably, if the shaft was all the way down, I don't know, they still appear to be closed. Maybe there's a greater problem here than I thought. Either that, or unless the start contacts are so pitted that the start winding wasn't receiving any power. Take you off the tripod here. Go in close. Well, we got to figure out what all this backlash is about. That's certainly not acceptable. Well, I guess you could tell I'm not a pump technician. I bet you at least a dozen of you guys out there were watching me try to get this impeller off and saying to yourselves, doesn't he know that thing is threaded on the end of the rotor shaft? Sure enough, wasn't even tight. So I was just happened to be checking for backlash to see if I could get an advantage on this thing to pop it off, and sure enough, spun right off. So that's not to say that impeller can't come off of there. Obviously it can, but in that case, I'm not even going to worry about trying to pull that off of there. So impeller, little spacer bushing, and the actual rotor shaft, motor rotor shaft. So bottom housing here has what looks like a ball bearing in it. A little bit of slop in there, that's for sure. Yeah, that's due to be replaced. Not sure where all that end play was coming from though. The bearing definitely doesn't look like it's moved in its housing. Held in there with a retaining ring. A lot of grease in here though. Wonder if it overheated and spit its grease out or something. It's kind of peculiar. There's a number on there, so I can order a new one. Hoover. It's a Hoover bearing. Okay. And looks like some kind of seal down there as well. Almost looks like a felt seal. Okay. Again, not really sure why there was all that end play in the motor shaft. That's very peculiar. I'm gonna say, you know, maybe it was designed that way, but I've never seen something with, I mean, easily an 1/8 inch of end play. There's the stator windings, they look fine. This motor is fairly clean on the interior. I think the problem might have just been those start contacts. Yeah, they sure are pitted there. Can you see that? Gonna clean them up. Let's do that right now. Gonna get a file, clean those contacts up, reassemble the motor, and see if we can get it to start without complaining. Alright, let's go ahead and get in here and run a file across these contact points here. See if we can't clean them up a little bit. Saying we can't really take this apart. Everything's been spot welded or riveted together, so never going to be able to get them perfect. But if I get them pretty clean, we should be fine. This material actually feels fairly soft. It's kind of surprising. I'm not sure what these are made out of. Usually, like ignition points, these contacts are fairly hard. That's quite clean now. Well, that might have been a little bit more aggressive than I should have gone, but let's see if I can run a little piece of Scotch-Brite through there now. Might be a bit difficult. I don't want to distort anything too badly. Okay. I think a little blast of compressed air across that and put it back together. You see those contact points now? They're looking pretty good. Alright, let's put it back. Alright, let's plug her in and see what happens. Running. See, you can hear this centrifugal switch operating there. Let me zoom in on that. See if we can show you what's going on. So keep your eyes in that grill there. If I set this light here, maybe you can see what's going on. That click is the switch, centrifugal switch, moving back to its resting position. The only other thing I noticed is obviously we still have all that end play. Here's the, see if I can get you a good shot of the tip of the shaft here. Yeah, all that end play. So watch that shaft when I start the motor up. So we're just going to leave it in a random spot right about the center here. Center of its travel. Ready? Sorry about that. Camera cut out on me. Let's try that one more time. It's interesting. So you can see that right now the shaft is it's not all the way to one extreme or the other. It's not all the way back. It's not all the way forward. So it's interesting. The motor itself, when it starts, it wants to push the shaft out this way, but then once it gets up to speed, it wants to kind of come back, but not all the way back. So what we're going to have to do is measure that. Start the motor and measure the where the shaft is in relative to the housing here, so we can figure out where the shims need to be placed. Well, it occurred to me after I said it that it doesn't make much sense to measure and cut and manufacture the shims to keep the rotor centered without first replacing the bearing. So I'm definitely going to replace this ball bearing here, and rather than go through the effort of cutting some shims and getting everything lined up and have to take it apart, replace the bearing, and some measurement vary in some way and needing to re-shim it, I'll just get to this next weekend. I'll order the bearing and hopefully it'll come in and we can finish this video then. But you can hear the bearing. Yeah, definitely pretty sloppy there. So got everything set out here, and a new oil seal as well. This one doesn't really seem bad, but it's as old as the machine, so it's worth replacing for what it's going to cost. And then pick up a new filter if I can determine what would be a suitable replacement for that, and we'll get back to it later. So appreciate you watching, and stay tuned for more.